how to convert a binary number to a hexadecimal number. In this tutorial, we will describe how to convert a binary number to a hexadecimal number. For example, let us convert the following. Alright, we're going to convert a binary number to a hexadecimal number. For this example, we're going to convert the binary number 110111101111 to a hexadecimal number. Before we begin, we have some notes to the right. We're dealing with the binary system. There's only 2 digits in the binary system. And when we have the value 0, it represents off. We have the value 1, it represents on. So let's compute. So to begin, how do we convert a binary number to a hexadecimal number? This is easy. All we do is very simple, is start looking at groups of 4s. Alright, so we're going to convert each group into hexadecimal. Alright, so what we have is we start off with 1, 1, 1, 1. And we always said you look at the position when you're dealing with the binary numbers. So we have 2 to the 0, 2 to the first, 2 to the second, 2 to the third. And what this says, since all these are on, we want to add up. 2 to the third is 8. We have 2 to the second power represents 4. And 2 to the first power represents 2. And 2 to the 0th power represents 1. This adds up to 15. And 15 in hexadecimal is represented by the value F. And so we say that this group represents the value F. Alright, so let's take the next significant group. We have 1, 1, 1, 0. Once again, we have 2 to the 0 power, 2 to the first, 2 to the second power, 2 to the third power, and we look at the values that are turned on. We have 2 to the third power, 2 to the second power, 2 to the first power. These values are turned on. Notice that 2 to the 0th power is turned off. So we add up 8, we add up 4, we add up 2. What we get is a value. Let's see, 8 plus 4 is 12, and you add 2, you get 14. So that's 14 represented in the decimal system is equivalent to E in the hexadecimal system. So that says that this group here is represented by the letter or the value E. Alright, so we look at the next group, which is 1101, and let's do it again. We have 2 to the 0th power, 2 to the first. These are the positions, 2 to the third, and we look at the ones that are turned on. We see we have 2 to the third turned on. We have 2 to the fourth, 2 to the second, and also 2 to the 0th. So we add 8 plus 4 plus 1. This comes out to be 13 in the decimal system. And this equates to the value D in hexadecimal. Alright, so we have the value D. And so this is our representation of 1101, 1110, 1111 in binary is equivalent to D, E, F in the hexadecimal system. Now let's test. We want to test and show by converting this hexadecimal number. We're going to convert it into the decimal number system, and our expected value should be 3567. So also here everything's by position as well. So F is in the 0th position, E is in the first position, D is in the second position. So let's break it down. So we have D times 16 to the second power plus we have E times 16 to the first power. Then we have F times 16 to the 0th power. Let's break it down further. We'll go ahead and convert the D represents 13, so this is really 13 times 16 to the 2nd power. Let's go ahead and break that down. Let me just step back for a minute. So 16 to the 2nd power is 256. And we say E is 14 times 16. And F represents 15 times 1, because anything to the 0th power is 1. So let's compute. We have 256 times 13. That's a value of 33. 28. And then we have 14 times 16. It's a value of 224. Plus 15 times 1 is 15. And so this equates to, see, 33, 28 plus 224 plus 15. And it equates to a value of 35, 67. And this is in the decimal system. And this is just a test to show that this is correct. And this is what we wanted to show. Next, let us perform another binary to hexadecimal conversion. This time we will convert numbers with a decimal point. Alright, so we're going to compute, and we want to convert a binary number to hexadecimal. This time we're going to use numbers with a decimal point. So we're going to convert 1001, 0000, 1101, 0.0001, 0001. We're expecting to convert this to hexadecimal, and then we're going to test it and convert that to decimal, and it should meet and equate to 2317.066400625. So let's compute. So the same thing again we said when we were converting from binary to hexadecimal. We want to look at grouping things into 4. So let's start here and start grouping them. Okay. So we know that 0001, that's equates to 1. That's simple. And also the next group is 0001. That also equates to 1. These are hexadecimal values here. All right, so also the decimal point goes there. And let's try to break down. So we have 1, 1, 0, 1. Of course, that's, look at the positions, to the 0, to the 1, to the 2nd power, to the 3rd. We have this one turned on. We have 2 to the 2nd turned on, and we have 2 to the 0th power turned on. So that means we're going to add 8 plus 4 plus 1. That's a value of 13. And that comes out to be the value D. So let's say this group here represents the value D. All right, so we have all zeros here, so that says this hexadecimal value is 0. And then we have this final one, 1, 0, 0, 1. We look at the positions. And the ones that we have turned on is 2 to the 3rd power and 2 to the 0th power. So we add that up. We have 8 plus 1 equals 9. All right, so this is our hexadecimal value. Now we want to test to show that when we convert this to decimal, it's going to equate to 2317.066400625. let's clear some space up. And there's a few things that we're going to need, because we're going to show that anytime you have a value towards the right, it's a negative exponent. So in this case here, this is really like 16 to the minus 1 power because it's in the first position, and it's also 16 to the second power. And so what we want to do here is show that when we have 16 to the minus 1 power, that equates to 1 over 16. So with that value, it should be 1 divided by 16, and it should be a value of 0.0625. Now also look at 16 to the second power. It equates to 1 over 16 squared. And we said that this equates to 1 over 256. And so that's the same as saying 1 divided by 256. And that number adds up to be 0.00396062. Alright, so these are going to come in handy. Okay, so now we have D. We will start off with, let's see here. So this is in 16 to the 0th power, 16 to the first power, and 16 to the second power. So this equates to be 9 times 16 to the second power. And we adding up 0 times 16 to the first power. Then we're going to add, now D is 13 times 16 to the 0th power. And we're going to add 1 times 16 to the minus 1 power. And we're going to add 1 times 16 to the minus 2 power. So let's break these down further. We said 9, and we said that 16 to the second power is 256. And so we have 0 times anything is 0, so let's put 0 there. And then we have 13 times 16 to the 0th power, that's 1, so it represents 13 here. And let's put this in parentheses. And now we have 1 times 1 to the 16 to the minus 1 power, and we just showed that up here what that value is. So that value goes here. We have 0.0625, and also we have 1 times 16 to the minus 2 power. We also show that that's what this value is, so we add it in the computation. So 0.0039062. Now let's add it up. We have the 9 times 256. Let's go ahead and clear that up. It's really 2304. Alright, so we add 2304 plus 0 plus 13 plus 0.0625 plus 0.0039062, and it comes out to be this value, and this would be in the decimal system 23170664, and this is what we wanted to show. This puts us in a position for my next tutorial where we describe how to convert binary numbers to octal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also feel free to join us here at the Computing Sector. There will be more videos and tutorials coming soon. Thanks.